Discussion on cybersecurity and data privacy challenges in software defined. And first, I would like to call upon the stage our moderator, Mr. Kamal Sood, Senior Manager EY-Parthenon. Can we all give him a huge round of applause, everyone? Come on. We have our speakers, Mr. Ganesh Subramanya, Head OT and IoT Security Services, Cybersecurity Business Unit, Tata Consultancy Services Limited, and has 22 plus years of experience. A huge round of applause for Mr. Ganesh Subramanya, everyone. I want everyone to keep clapping, come on. Next up, we have Mr. Tejas Lagad, Director for Asia, Middle East, Africa at Nexus Group, 20 plus years of experience that spans across product management, software engineering, and consulting and sales. A huge round of applause for him, Mr. Tejas. Next up, we have Mr. Harsh Kumar Singh, Lead Application Engineer, Functional Safety and Cybersecurity, CADFEM India Private Limited. A huge round of applause for Mr. Harsh. Next up, we have Mr. Mandeep Bhandari, Director Sales, Aeris Communications, 15 years of experience. His expertise is to derive innovation in the automotive industry. A huge round of applause for all the speakers and our moderator. Thank you.
Hi, good afternoon, everyone. So I think we are just in the way of hot tea or coffee after lunch, right? So, but the topic is interesting. I think cybersecurity and data privacy, right? And we won't take much time, but nevertheless, let me start with, I mean, we have a esteemed panel here, right? All the experts in the field. So let me start with Ganesh, right? To set the context, I mean, now we are moving in the era of, SDVs as well as, I mean, we are currently having a lot of connectivity in the vehicles, right? And the internal software architecture is also something which is evolving, right? And to start with, we would just like to understand, Ganesh, that how the risks, or the threats are different when, in case the vehicle is just software defined, rather than connected, and when it gets connected, right, then how it gets amplified, right? If you can, we can just start with that for the audience.
Yeah, thank you, Kamal, for that. So I think before I start on that topic, what I noticed today is, throughout the various topics that have been covered since morning, there has been mention of cybersecurity along with safety, right? So that underlines the importance of cybersecurity for a software-defined vehicle, or even for a regular, connected vehicle architectures, right? Now, what's happened with the software-defined? Of course, we are moving towards more and more code. Now, your traditional vehicle today itself have millions of lines of code, right? And with the SDVs, that's simply going to go into billions and more, right? And of course, as you go more, into a software-based architecture, managing the security of that code, ensuring that code is secure itself is one of the challenges, of course. Now that again, with the SDVs, you're possibly looking at reducing number of actual ECUs. You're going to have more of domain ECUs, centralized processing, etc. So, a lot of the capabilities that are distributed are going to be centralized. Now, that's also means that the risk profile of a particular component which is controlling multiple systems, many of them could be safety critical systems, and if that's compromised, you're putting safety on the line, right? So that's from a code perspective. Now, when you look at the entire ecosystem of a vehicle, right, of a software-defined vehicle, etc., it's not only about what's in the vehicle, right? While that's moving to more software, but there's a lot of connectivity outside, right? For multiple reasons. Could be, infotainment. So, that's a user experience that people expect in these vehicles, that they get access to infotainment content, and that means there is an infotainment system somewhere streaming content into your vehicle. You also, of course, will have the expectation that the software needs to be updated. It could be feature updates, it could be configuration updates, it could be simple patching for security vulnerabilities, which is also important, and all of that is going to be over the air, right? So you'll have a system that is pushing updates. And then there are others, right? You already have mobile applications, you have web applications that you can use to connect to your vehicle. So you have this ecosystem of applications that are outside the vehicle, and you have the connectivity between your vehicle and those systems. We expect in the future, of course, as 5G gets adopted more, that connectivity is going to be more of 5G, and that needs to be secured, right? So the connectivity between the vehicle and any of the applications that are hosted in the cloud, or it could be from a third-party service provider, all of that is going to come over a network channel. And if your application on the cloud are compromised, that's a vector into the vehicle, right? So there's a conversation I was having with one of our customers on, so what if there are vulnerabilities in the vehicle, right? Are they more critical, or should I focus more on the vulnerabilities on my applications? Because if I had to exploit something in the vehicle, I need to be physically near to the vehicle, or at least get access through NFC or Bluetooth or something, but I need to be physically near to the vehicle. While if the applications can be accessed remotely and so on, that's a more easier target for attackers than being near to the vehicle, right? So what this means is also from a OEM perspective as well, you need to look at what are your priorities in terms of threats and risks that you need to handle first. But having said that, again, if you're able to get near the vehicle, there are multiple ways to get in, right? There are physical interfaces through which you could get into the vehicle. You could do things like key fob, replay attacks and so on to get access to the vehicle, get into the vehicle, connect to the infotainment system, and get into one of the software components within the vehicle as well. So it's important, I think, when you're looking holistically to do a threat model, look at the various interfaces your vehicle have and identify the risks that you want to deal with, right? Yeah, I think one more aspect I think I missed on, since we have it on the agenda as well, on privacy, right? Now, with SDVs, right, we are looking at more and more features, more customization that users can possibly do in the future. What that means is you're going to gather and process more personal information about the owner of the vehicle or the driver of the vehicle. And that brings in the privacy angle in terms of how do you handle that data, comply with the various regulations. India is also coming with the privacy regulations, etc. So how do you make sure you ensure that? So that's going to be an additional aspect to consider also when you're looking at SDVs and a lot of personal information being processed.
Great. Now, since we have understood, there are multiple ways or multiple touch points, right, from where the threats can, come into the car or to the driver, right? So these are the potential vectors. So my next question would be to probably Harsh, right? So, how we can kind of model these threats and try to mitigate them at the requirement stage itself, right? So that it's more of a proactive approach. How we are doing it, at this point of time, and what's the roadmap towards it? Towards improving it.
So when we talk about how to model threats, or let's say how to deal with them at earlier stages itself. So right now we are moving towards a MBSE period, right? Model based systems engineering period, right? And why MBSE? Because majorly it is way too much representative in manner, okay? And it's easy to understand by any other, let's say if there is a relation between an OEM and supplier, right? So obviously there is a very representative manner to define those systems, right? So what happens, let's say when you are talking about these requirements, okay, at the earlier stages. So it's not about just the requirement, let's say on the entire project basis, but it will also be having the safety and security requirements. Now for that also, let's say if you want to set up the connectivity with different teams and everyone, right? So what you usually do is you follow a model-based approach in order to perform this cybersecurity analysis in compliance with ISO 21434, and for ISO 26262 also we follow a model-based approach. So what happens over there is, let's say it gives you a proper holistic overview of the entire system, that what exactly you need to look into, okay? And obviously once you are defining the model, right, it gives you an option of iterations because it is not a one-time process. Okay, so if you talk about cybersecurity analysis or any functional safety analysis type of a thing, what happens over there is it requires a lot of iterations. So their model base like modeling a threat, right, it plays a very major role for the iteration purpose, so that you can redefine the requirements and make it much more better architecture at the software level.
Got it. And probably moving to the next point, I mean, I'd like to bring in Tejas also here. So, so one aspect is to, try to mitigate, try to model this risk and try to proactively mitigate at the requirement stage. The other is also to develop solutions, right? How to kind of then lower down the risk. And one of the things is identity solutions, various handshaking protocols, so that there is a sanctity in the system and less chances of breach. So could you please elaborate on that how these solutions work and how we are trying to improve even further on that?
Yeah, I think yesterday's fiction is today's reality, right? Just a few years back, maybe 20 years back, we used to play around with remote controlled vehicles in our living rooms. And now, we have actually remote control vehicles out on the road, potentially which can be converted into a guided missile, especially now with the world we are living in with exploding charges and walkie-talkies. It becomes even more important for us to go ahead and secure them. So software-defined vehicles might be new, but luckily for us, software is not new. So to find solutions, we, just like our earlier speaker said, we can obviously go back to what is already evolved over time and go back and seek inspiration from it and remodel it to what will suit our purpose, for vehicles as well. And one thing which has served us for a very long time, is the concept about identity and identity-based zero trust, which has been evolving over the last 10 years. So what is working currently very well for the connected vehicle ecosystem, and is now being adopted for SDVs as well, is the concept of identities based upon digital certificates, which have been worked for humans and now are being repurposed for vehicles as well, where we can deploy a certificate on a vehicle, deploy the same on the telematics, or any connected system, so that you create a fabric for authenticating the device, authenticating the server, and set the channel for us to go and have a trusted communication between both the components, encrypt the communication, both ends. And of course, when you go ahead and send a new software over the wire or a firmware update, we know that it is actually digitally signed, so that the receiver knows it comes from a trusted source. So the tried, tested concepts can be repurposed, for the SDV to be able to go ahead and solve the problems.
But I mean, recently we also had this, I don't know, it can be categorized as a cybersecurity breach, the latest Microsoft, the entire Office 365 kind of getting shut down right now. So I don't know whether to kind of categorize as a security threat, but like you mentioned, the software has always been there, and there have been measures to kind of, reduce this, but still these kind of large outages happen, right? So what's your point of view on that? I mean, what are the potential still gaps out there, and how do we kind of plug those gaps, in future? Yeah.
So a couple of things, Kamal. One is the impact of a breach in pure IT or software systems compared to in IoT, or a connected vehicle system is hugely different. There was never a risk of life, when
right.
Microsoft.
Yes. So here the drivers are in the car, people are in the car, right?
Exactly.
Yeah.
So the severity is many scales higher, which obviously brings our focus back to the need to implement secure mechanisms. So while, for example, and I can take some references, from other IoT devices, where many verticals have not yet seen the need to deploy an identity-based trust system. Here, luckily, the vehicle manufacturers have seen the need and are doing it at an inception phase or a design phase, as Harsh was saying earlier. So that's a good thing for us. Secondly, what is happening is new attacks coming in forth, like the supply chain attacks. I think the The pager attack that we just saw, and thankfully did not experience very closely, is also an example of the same. That we need to identify every element that goes into the vehicle uniquely. And again, going back to the concepts about what has worked for us, if at all we are able to go and identify every element uniquely through use of technologies that are already there, certificates being one of them, it allows us to go ahead and ensure that the entire supply chain is secure. That when you actually, earlier I was talking to somebody and he was saying that the right to repair a vehicle, is going to kind of take a backseat with SDVs. But if at all you want to be able to go and do a right to repair and you want to take a part from the second market and being able to go ahead and fit into your device, you still need to know that it actually comes from the manufacturer who claims to have manufactured it. And that's again the way certificates can be used to ensure that the print certificate that you have on the device, the factory certificate that you have on your device, is actually verified before you make it as part of your CAN bus or the ecosystem within the car. So again, challenges are new. However, the solutions are existing and tried and tested, so we can reuse them.
My next, maybe Mandeep, we can discuss on the regulatory framework probably, right? So although we are talking about measures which we are taking across the supply chain, right? The OEs and the partners, right? But how is the regulatory framework kind of helping in enforcing cyber security, right? What are the various acts there? And yeah.
So, Kamal, if you see, there are various regulations that are in today's scenario. If we talk about regulation, there is a regulation called R155, R156, which tells you what to do, but it's just a thing. On the similar lines, there is two other regulations. One is ISO 21434 and ISO 24089, which both are applicable to your cyber security. One is for your system that is already exists in the cloud, and then there is a system that you deploy for your key updates. Then on the same lines, there are other regulations that are getting discussed in India as of now, are AIS 189 and AIS 190. Again, both are applicable. One is for your cyber security management systems, and second is applicable for your software management systems. So these are all frameworks which tells you what has to be done. But one thing is very clear, what they say is it has to be applied across the supply chain. When they say across the supply chain, it's not the responsibility of OEMs anymore. It has to be taken care at supplier levels as well. The tier ones, tier twos. Everyone has to contribute in this, because they have given you a checklist of requirements. They are asking you to maintain documentations. They are asking you to validate the threats, or basically they call as Tata, which they want you to do threat analysis and risk assessment for all the components that you're supplying. And they are asking that any incident that is happening, you have to report it, you have to document it, and then you also have to document it what basically how you overcome. So that all records has to be. Similarly, in the case of OTA side, what they're asking you is to maintain the complete software that has been updated. What is the software versions that has been done? What is the new features that has been introduced with this software updates? So all those documentation, record management are these regulations are asking you to maintain. The idea is basically, and they're also asking you to do it in a continuous way. Continuous way is a continuous improvement, that this has to be done periodically, audits has to be done periodically, and even if your vehicle approvals, your new launches will also be defined by your capability to maintain these regulations in place inside a room. That's how they are maintaining these regulation frameworks to be implemented. I think it's already implemented in EU, Japan, Australia, and most probably it will also go back to our continent as well, I think, in the future as
well. So one other trend which I have observed, I'm also learning SDVs, right? So one trend is that there is a centralization of the software architecture, right? From different ECUs to a central, more high powered computing, right? my question was that does it really increases the probability and also the impact of threat with the centralization? I mean, because now you are concentrating the power in just only one HPU rather than in multiple, ECUs, and those were kind of distributed. Now we are centralizing, right? So if an attack has to happen, right, cyber attack, and if there is only one device to kind of, so does it increase the probability as well as the impact? I mean, I just want to get your views, not to any specific person, but open to hearing views on that.
I can go first. So answer is yes, of course. I think again the Microsoft hack you spoke about, is perfect example. Earlier people used to have enterprise software and a local push, for any antivirus updates and agents, and that worked well, of course, for many different years. And now, with vendors coming in, we are trying to go ahead and centralize all the agent updates to a cloud server. And of course, when you have a cloud server involved and that gets hacked, we can see the impact is much more widespread. I think it's both a challenge as well as an opportunity. The opportunity there is that if at all you have to do one thing properly, it's just easier for us to go ahead and put a good, strong process behind it before you can actually kind of roll it out securely. And if at all you do that one thing well, then of course, the entire kingdom becomes secure. So it's a bit like having, one key to the entire kingdom philosophy, where when you had multiple passwords all over the IT network, and you have to remember 10 different passwords, each of which changing, it became a big challenge. But when single sign-on came in, you said, okay, you have one strong password, and you further supplement with the multi-factor authentication, it becomes easier. So I think the same principle applies to this centralization concept as well. I think it's an opportunity for us to go and do that one thing right, so that everybody can benefit from it.
Yeah, so I think I briefly touched upon that, right, when in my initial comments as well, right? So with centralization, right, or let's say, we have this saying, right, with great power comes greater responsibilities, right? So while centralization of all the capabilities has its pluses and it adds a lot of value to the vehicle ecosystem and the architecture, etc., the risk cannot be ignored as such, right? That's where I think when Harsh was talking about doing the requirement analysis, doing the threat and risk assessment, etc., the perception of the risk of this ecosystem now is different when you have multiple distributed ECUs versus centralized, right? It should also not become a single point of failure, right? If somebody is able to shut down that particular system and it's controlling multiple systems in the vehicle, what is the impact? So that needs to be looked at as you do it developing of that vehicle, and increase the amount of measures you put in terms of securing that particular component, right? So that's one important aspect, I mean, that the OEMs need to look at. Second is, and another point I probably missed talking about, which is the supply chain part of it, right? So when you develop this centralized components and so on, you may end up using multiple third-party or open source libraries, etc. And it's important you keep track of that, right? Have that software bill of material and be able to keep track of any vulnerabilities that are being reported on those components. Or if you're getting a part of the system from one of your suppliers, how do you validate the security of that? So all of that becomes more important as you, club everything together, right, into one centralized system. And the last point is, because it can be a single point of failure, and you should also design the architecture of that component in a fail-safe manner. And I think that's something that is native to vehicles or any IoT systems or OT systems where safety is critical, that you always have a fail-safe mechanism, and that should be part of the software ecosystem architecture as well.
So basically you have covered the component level. Okay, so actually, yeah, component is one of the part obviously that we need to look into. But apart from that, let's say when we are talking about safety aspect of that, centralization. So obviously you need to see that, okay, the functionalities are getting added onto a single ECU, right? So that's where the main problem is. So if you're centralizing that thing, obviously we are advancing the systems, but the other impact will be like, if one thing is getting failed, obviously there will be a propagating effect, right? So for that, let us say, people are already trying to, merge the safety and security aspects right now. Okay, they are finding the ways like how we can, because right now people are working parallelly in these two domains. Okay, and now since these things are happening and we are moving into SDVs, people are checking for these, merging of two standards, three standards. Even people are talking about concepts like SOTIF now, right? So we need to look into these aspects like how we can merge. So for merging these type of things, what you need to do is you need to focus on the software application itself, because when we talk about the cyber security, it's nothing but a coating over the application. Okay, you are making it secured. Okay, so let's say if you have the context, you have a particular architecture model at the top level, you are performing the functional safety for that. But let us say you are performing the cyber security for the same context. So once you define the requirements or the goals, like let's say the goals, okay, now you have to redefine it. So where you can redefine these things, you can come back to again to the software level, where you can perform the functional safety on the software level, get the impacts on the safety front, as well as perform the same security, like cyber security analysis on that particular software architecture, where you can merge the same, cyber security requirements for the particular goals that you have dedicated, because ultimately your safety requirements are getting to the safety goals. So you have to make sure that these two should be on the same level that you're operating, right? And again, obviously, if these things are getting impacted, your hardware failures and all these things might come into picture, right? So yeah, so merging these two things are not easy, but yeah, it's a recommended process that, one can follow to make sure that you specify the requirements, not just the goals for your cybersecurity process. Okay, so yeah, that's it from my.
Next thing, again, going back to the same topic, just an open question, right? So now, because of centralization, right? So how do you see the liability of it also getting concentrated, right? When we talk about supply chain, right? Now there's a central ECU, and probably OE will have the vehicle OE will have more control over it, right? Does it mean that the liability also increases much more towards OE than the component supplier? I mean, how do you see that liability landscape evolving, and what do OEs need to do, kind of build capabilities to address that?
I mean, for OEMs and the suppliers, let's say we are talking about them, right? So obviously we need to have that sort of a tool chain where they can have a shared bondings and all these things. Okay, so for that, what I have said in the starting itself, that MBSE is one of the approach that one is looking into that, right? So model-based systems engineering is one of the approach where people are connecting, and it is way too much easy to represent everything. Okay, so it becomes very easy for the OEMs to express their problems independently, and from there the tier one can catch up from those problems, and they can work on their particular parts. So basically it becomes very easy to represent everything. So anyone else?
So I would say, in this sense, yes, liability will increase uh, because it's a central compute that is controlling everything, and it's under control of OE. But I think liability will also increase parallelly for suppliers as well, because it's a single compute being supplied by someone else, which is run by OE, managed by OE, but is getting supplied by someone else, right? So I'll say again, it will balance out itself in a broader context if you look at it in that way.
Probably next, I think, Tejas, if you would like to talk about the V2X kind of connectivity era which we are moving, right? A lot of data is getting, even the private data gets sometimes shared to provide the services, right? So does it mean that we need to sacrifice privacy over security, right? So yeah.
I think it's a very important topic. And of course, we all realize the promise of V2X, right? We've all seen ambulances, and fire engines get stuck in traffic, for years now, without a proper resolution. And then in comes V2X, which says that we will actually go ahead and give an identity to every emergency vehicle, which will be then able to communicate to every roadside equipment, including, let's say, signaling stations, and communicate to them that, hey, here's the emergency vehicle. If you can, please create a safety package, which means go ahead and turn the next few signals green, so that the car can accelerate. So the promises are fantastic. What happens in this scenario, which we may not all realize, is the signal captures all the data about all the vehicles around it all the time, which brings in not a safety or security risk, but more of a privacy risk. So if at all that signaling station, then gets hacked, you can actually kind of find out, okay, who was here at certain point in time. Now here again, the solution is to not compromise, on either the safety or the social impact of V2X, but to actually go ahead and balance it out, with the concept of, again, digital identities. What has worked for, let's say, the V2X launches that you've seen, in Europe and the US, and we're trying to drive the same, within emerging economies as well, is that the identities that we give to the vehicle are not a single identity, but what is called as a pseudonym identity, which means the vehicle actually not gets one, but a stream of about 100 identities, which it keeps on changing every week. So every interaction that the vehicle has with a neighboring vehicle, which is turning around a corner and trying to come at a very high speed right in front of the vehicle, the identity that is interacting with that vehicle and the signal station and the vehicle behind it, etc., it keeps on round robining through the entire set of identities that is given to it, as a batch, which creates a different problem now, which is when you want a vehicle to go and create that many identities, what is the compute available on the onboard unit or the TCU to be able to go and generate that many identities? That has again forced, a new evolution in identity space, which is called as butterfly algorithms. So with the algorithm like butterfly, which my company Nexus is one of the pioneers of, is that you can create a one key pair on the vehicle, okay, a single identity, and through it you can kind of create derived identities with a very high entropy, which means a very low chance of collision, which means every identity can be unique, and an entire set of 100 identities then pushed out to the vehicle when the vehicle is in the connected space and has access to data, so that you can kind of push out that identity and then use that for communication all across. Now this allows you to go ahead and not compromise, as you mentioned, Kamal, on the safety, and the privacy aspect. So you can be safe, because you can communicate freely, because you're communicating that you are a vehicle that is coming across, at a certain speed to you, and you can kind of communicate that you are an emergency vehicle, but not necessarily reveal your VIN or anything that is unique to you, and still be able to go and communicate freely. So yes, there are challenges, but of course there are solutions which are evolving as well.
My next question would be to Mandeep. As a partner who offers connected vehicle solutions, right, to a OE, right, how they can help really in complying with the larger policy framework guidelines, right? What are the checks and balances? What type of integration maybe is required, to comply, and what kind of joint development or where do they start to need to start integrating and to have the larger compliance? Yeah.
So if normally when we work with our customers, we work with them from starting from the concept phase,
Okay.
where we see what are the threats, what are the risks of these threats. That analysis starts from the concept phase itself. There we work with them because the data has to transfer from vehicle to cloud. From vehicle to cloud, we also provide this connectivity platform as well. So in that connectivity platform, we do have a product called Watchtower, which actually tracks the data that is getting flown from which IP to which IP. Is there any phishing thing happening? Is the data is flowing to the right IPs? Is the amount of data flowing is to the right IPs? And then the same check and balances are maintained at the backend level, where we see that whatever the data that has been transferred to our system is its integrity is maintained. Is there any data detection or anomaly detection that had happened in that hardware or from that hardware data? That is also getting checked at the backend level. Then what we do is we then also provide a data platform where we collect all the data from your and then provide it to OEMs, where they can also analyze the same data on a real-time basis, what's happening with the vehicle, particular vehicle, if there is any particular attack has happened,
if there is any malware that has entered inside the data or which is destroying its data integrity. That all checks and balances are being done, and these are being done working collaboratively with our partners, where they say that when they want to do, how they want to do, and then we use our expertise to see how these connections should happen. Even though it's an open system, but we have to maintain it as a closed system as well from the attacks, and that's where we bring in that checks and balances in place.
So as we are, I mean, as SDVs are still evolving, right? The software architecture is evolving. The kind of threats will also keep evolving, right? Their potential as well as the novelty in that, right, will also keep evolving. So what is the kind of capabilities which OEs will have to focus to develop inside? I mean, R&D, maybe in the infra, so on the data side, cloud side. So what are the key areas where they need to really invest and focus on going forward?
Yeah. So I think as Tejas or somebody mentioned, right, software is not new to us, right? We have been doing IT software for such a long time, but maybe not to that extent in the vehicle space. Right? So it's about upskilling and getting the right skill set. So in the in the SDV space with high compute, hypercomputing, etc., and also more of maybe container-based architectures coming in, with more of microservice-based architecture coming in, right? This expertise is something that we have in the other industries, right? That needs to come into the vehicle space. But then those coders or the developers probably don't understand the vehicle domain. So that's the level of upskilling that is required, right? To address the skill challenge that we'll have when we start, doing this on a large scale development of the SDVs and management of those platforms, right? So that is one in terms of the skill set point that you mentioned, right? Now, as we look forward, I think there are other threats we need to look at also. One of them, a topic I talk very often in my other role in my company is around quantum, right? Now, quantum, many of you have heard about quantum computing and the advancements that are happening in there. And we expect it's just a few years away when quantum computers are available at least to the motivated hackers, and they can use it for launching attacks. And the issue, the prime target is the traditional contemporary, what we call classical cryptography that is used almost everywhere. It's extensively used in the vehicle ecosystem even today. Not even in the SDVs, in the regular ones also, for identities, certificates, uses encryption, cryptography that is vulnerable to quantum attacks, right? It's used in multiple places for secure communication within the vehicle, for identifying different components of the vehicle, and so on. And the other aspect is that the vehicles that are manufactured today are going to run for next 20 years, 15 years, or longer. And somewhere in that life cycle of the 15 years, these quantum computers are going to be around. And your crypto that is in the vehicle that is deployed today is vulnerable. Now, with software defined, possibly you have the ability to change that crypto over a period of time, provided you designed your applications, the compute and so on, to be agile, or what we call crypto agile, right? So that it enables easily remotely upgrade of the crypto from whatever you're using to a quantum safe. So that's something we also to be thought about as we develop these new vehicles, to make sure we're able to upgrade on the security side as well.
I'll just add a bit to it, because we touched upon this very important topic about crypto agility. Luckily for us, we already have guidelines, for the next set of algorithms, which will allow us to go and be secure for the future as well. So the traditional RSA and ECC algorithms have been evolved into new algorithms like Sphinx, and Dilithium, which are kind of taking form. Luckily for us, vendors like Nexus are the ones who are already providing a system which is compliant to the upcoming standards. So if you go to our website nexusgroup.com, feel free to sign up for a free service that we are doing for the entire IT community, where you can go ahead and start using the new set of keys with the new algorithms and use it for both product development as well as testing as well. So I would really encourage all of you to explore the new algorithms, because this is the time to start now. Because if we don't, as we mentioned right now, that if we don't do it now, there's a big threat that people will start simply going ahead and capturing data, storing it for a very long time, and waiting for the quantum computers to come in where they can go ahead and de-encrypt or decrypt all the traffic that we currently have encrypted. So it's going to come in a very few years, and the time is now to start experimenting with it before it starts affecting us and our customers.
Great. I mean, definitely kind of enthusiastic to kind of or feeling bit positive that we are doing because cybersecurity comes, I mean, as a vehicle user, right? It really kind of creates a lot of doubts when your entire vehicle is, software based. So anybody can hack, right? So, I mean, all of us can probably relate to it, and a bit of relief that we are moving in the right direction and having all the protection measures in place. So I think if any questions from the audience, I mean, it's an interesting topic. Anybody would like to, ask any question? It's open. I think none. Everyone is just waiting for the coffee. So I think we can wrap this up, right? Great. Thanks to everyone, the audience as well as the panel members.
Thank you.
Thank you.